If a series is like this, then this one is called a geometric series. So if it goes like this, geometric series, because what we can see is here, this is first term, this is second term, so there's a ratio. Second term over first term is r, so that every term is increasing by a ratio of r, and this is the, whenever it happens, we call it a geometric series. This r can be greater than 1 or it can be also less than 1. So if it is less than 1, let's say we have a series something like this, 1/4, 1/8, 1/16, so this is decreasing. While we can have a series like this, 16, 32. So obviously this one will reach to infinity after a while, so this has to be, it cannot go for infinity. But when it is a decreasing thing, it will become small, 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 this one. So finally we can neglect the very higher terms. Now this one, if we look at this one, the nth term is something like this, just like in in arithmetic series we had a formula for the nth term. Here also we have one. So this will be, second term is a to the power r, third term is a to the power r square, so nth term will be r minus n. This is the nth term. If we want to calculate the sum, let's do that. So let's say we have a term series like this, ar square. So if we add them all, a to the power r n minus 1. So if we multiply it by r, it becomes something like that, ar square plus ar cube plus r to the power n. So now if we subtract this from that, what will happen is this one will get cancelled, this one will get cancelled, everything will cancel, only this one minus this one will remain on that side. So this will become, so it will become a minus a to the power like that. So sum is 1 minus r, a 1 minus r to the power n. Now when r is less than 1 and it goes for infinity, the term, then the sum becomes, this term becomes very small, so the sum becomes a 1 minus r. It becomes very small because when r is less than 1, for infinity this is already smaller, 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 and finally the nth term becomes very small, so we can ignore this one. And the sum for infinity when r is less than 1 is this one. This is a very important relation which we will see in examples, and this one is for general when it's not infinity, a 1 minus r to the power n and 1 minus r, and this is how we calculate it. So I will do an example maybe later. Its magnitude of r has to be less than 1, so basically r has to be less than 1 or also less than negative 1. So if r is negative, it has to be less than negative 1, so it can be 0.1, something like that, 0.5, whatever, negative. So the magnitude of r has to be less than 1, not just r less than 1, because r can be negative as well. Basically I was talking about the series that goes up to infinity. This is the sum, and r has to be, the magnitude of r has to be less than 1, while this is the formula for general condition when the series goes up to a finite term.